Today, we're diving into a threat that's as sneaky as it is dangerous for your AI models, the label flipping attack. This isn't about hacking your servers. It's about corrupting the very foundation of your AI's knowledge, its training data.
You know, we spend so much time and effort making sure our training data, the images, the text, all of it is high quality. But what about the labels? What happens when the data itself is perfectly fine, but that one little tag, that simple description we attach to it, has been secretly sabotaged?
So, what exactly is a label flipping attack? Well, it's a clever form of data poisoning. The attacker doesn't bother creating new malicious data, they just change the answers to the data you already have. The flashcard analogy is perfect here. Imagine you're studying for a test. The card says Paris, but someone has sneakily written capital of Germany on the back. You memorize the wrong fact. That's exactly what happens to your AI. It learns the wrong pattern, creating a blind spot that an attacker can exploit down the line.
So here's our game plan. First, we'll uncover the business risk hiding in your labels. Then, we'll dissect how these attacks actually work. After that, we'll lay out a solid defensive playbook, and we'll wrap up with a clear action plan designed for leaders.
All right, let's jump right in. Section 1, the secret in the labels. We're going to talk about why this isn't just a tech problem. It's a critical business risk that needs to be on every leader's radar.
What makes these attacks so incredibly potent is just how stealthy they are. A flipped label doesn't set off any alarms. It just looks like a simple, honest mistake, the kind of human error you'd expect to find in any large dataset. And that plausible deniability is what makes them so tough to catch with a simple spot check.
And this risk is only getting bigger because our attack surface is constantly expanding. Think about it. It's not just your internal team anymore. Are you using outsourced labeling vendors, crowdsourcing platforms? Each one is a potential backdoor for an attacker. And that's not even counting compromised software tools, or, of course, the classic insider threat.
Okay, let's move into Section 2, the anatomy of a data attack. We're going to get into the nitty-gritty of how these attacks work and, more importantly, the real-world damage they can actually cause.
Generally, attackers take one of two routes here. On one side, you've got random flipping. This is kind of the brute force method. Think of it like just throwing sand in the gears. The goal isn't subtle. It's just to mess with the model, lower its accuracy, and make it unreliable. But then there's the other, much more sinister approach, targeted flipping. This is surgical. The attacker isn't just causing chaos, they're changing very specific labels to create a predictable, exploitable backdoor just for them.
And the numbers here are absolutely staggering. Even with that sand in the gears approach, just randomly flipping 10 to 20% of your labels, can tank your model's accuracy by 30, even 50%. For most business applications, that's game over. The model is effectively useless.
But this is the stat that should really get your attention. A targeted attack is ridiculously efficient. An adversary only needs to flip a tiny, almost unnoticeable fraction of the data. We're talking just 3 to 5% of the labels to build a backdoor that works for them over 90% of the time. That's a minimal effort for a massive, reliable vulnerability.
So what does this actually look like in practice? Well, the most obvious one is a security bypass. Your model is trained to see an attacker's malware as safe or their phishing email as legitimate. Or it could be more competitive, systematically flagging a rival's product as spam. And of course, there's always the general degradation, where trust in your multi-million-dollar AI system just erodes until no one wants to use it anymore.
All right, we've laid out the problem. Let's pivot to the solution. Section 3 is all about your defensive playbook, how you can actually detect and prevent these attacks.
A strong defense really stands on 3 pillars. First, there are statistical methods. A key technique here is called confident learning, which basically uses your own model to find labels it's pretty sure are wrong. Think of it like a self-check. Second, you've got process-based controls. A great one is gold standard validation, where you secretly slip in samples you already know the answer to, just to test your labelers. And third, there's model-based analysis, where you dig into the data points that give your model the most trouble during training. They're often hiding mislabeled data.
Now, this isn't a one-and-done fix. The best approach is a continuous cleaning cycle. You train your model, you use those detection methods to find likely errors, you send the flag data for a human to review and fix, and then you retrain on that cleaner dataset. You just keep running that loop, and each time, your data gets a little bit tougher to attack.
And that brings us to our final section,
the action plan for leaders. This is about stepping back from the specific techniques and thinking about how to secure the entire process from a governance standpoint.
I love this quote because it hits on a core security principle: separation of duties. This shouldn't be seen as just a best practice. It's a non-negotiable security control. It means that no single person or compromised account can take data from its raw form all the way to a production model. You're building breaks in the attack chain.
So what can you do right now? Here is your quick win. Implement that gold standard validation we talked about this week. It's so simple. Just mix in 5 or 10 samples where you already know the correct answer into every single batch you send out for labeling. It is one of the fastest, easiest ways to get a read on the integrity of your entire labeling pipeline.
So as a leader, your mandate really comes down to these 4 things. 1. Start treating label quality as a security vulnerability, not just a QA problem. 2. Mandate separation of duties in your AI pipeline. 3. Invest in a mix of detection tools, both process-based and model-based. And 4. Put your third-party vendors under a microscope. Really scrutinize their security practices.
So I'll leave you with this question to take back to your team. If one determined attacker manages to change just one single label in your pipeline, what's your process to find it? How can you be sure that one tiny change won't spiral into a corrupted model and a critical business failure?